Okay, we're going to talk about electronegativity, and electronegativity is, we're putting it in Unit 1, but it's not in Chapter 7, it's in Chapter 8. You'll find it in the bonding chapter if you want to read the book. Okay, so electronegativity is defined as the ability of an atom in a molecule suggests a covalent bond, to attract electrons to itself. Okay? So the more an atom in the bond wants the electrons, the closer those electrons, the greater electron density will be around that atom as opposed to the other atom. So this big purple is not just because chlorine has more electrons than hydrogen. The difference in shading you're seeing is based on just the two shared electrons between hydrogen and chlorine. And what it suggests is that those electrons are going to be closer to chlorine than they will be to hydrogen. That's what electronegativity is. So if you look at the trends, what you see is as you go across the periodic table, the electronegativities go up. And in fact, this does not use energies. It's a scale that was made up that has no units. The high was arbitrarily set as 4.0, which was the value set for fluorine, which is the element with the highest electronegatividity. And all other atoms' electronegativities are compared to fluorine. The other trend that you'll see is as you go down a group that the electronegativity goes down. Okay. So across a period, why is electronegativity going up? So if I think about going from an atom where I have lithium to beryllium to boron to carbon, I'm increasing my number of protons and my number of electrons. I'm increasing my Zeph. I have a stronger Coulombic attraction to the nucleus. Okay. When I go down a group, why is the electronegativity going down? And that's because as I go down a group, those outer electrons, where I am the ones that are bonding, the ones that are bonding are always the valence electrons, are further away from the pole of the nucleus. Okay? So we'll talk a lot more about electronegativity when we talk about bonding in our next unit. But in general, if you have a covalent bond between two atoms, and most of the time you find that between two like atoms, let's say two carbons, because their electronegativity is the same, this is a non-polar bond. Okay? If you have a bond between two atoms with different electronegativities, that bond will be polar. The electrons will be closer to one atom than the other. And in the extreme case, where you have a positive and a negative, not just electronegativity difference, but a positive and a negative, this is ionic, these are molecular, right? These are covalent, then you would have an ionic bond. Alright, so here's just a quick question to see if you understand electronegativity and how it compares to ionization energy and electron affinity. So give this some thought and think about what's happening. Okay, so if I think about electronegativity, what's causing something like fluorine to take on more electrons is the fact that it is small and it is attracting electrons to itself. It's going to have strong electron attraction, and if the electrons are strongly attracted, it's not going to give them up very easily, so the energy to ionize or remove an electron is going to be high. And electron affinity is the energy typically released when you add an electron. So if you add an electron, it becomes more stable. You're going to have a high negative electron affinity, so the choice is going to be number 1 for us.